Okay, in previous videos we talked a little bit about SQL and databases in a very oversimplified way of how they work. So in this day and age we have had this technology of collecting data for long enough that we have so much data in our hands. And some of it's too much. So there's things called data warehouses and lakes that store this huge amount of data. Now, the term, according to professionals, are not synonymous, warehouse and lakes, but they are kind of similar. Think of warehouses kind of like Walmart, where there's aisles and aisles of things that are in different categories, and there's just so much. But when you go to the store, as much as you'd like to, you can't take the whole store with you. You only take a specific amount from specific rows and aisles, and only according to what you need at that time. A data lake is something, think of it like this. When people want to dam up something, or they want to make a lake, what they do is they build a dam so that water collects and gets big enough so that it's a reservoir or a lake. Once again, that's an oversimplification, but the point of this is that a lot of businesses have data lakes where they just push all the data that they collect into this lake. It could be unorganized, it could be kind of sloppy and unformatted and things like that, but the purpose is to just collect as much as you can, analyze later. So there's lots of different warehouses and lakes. Some you may have heard of, some may not have, like Amazon Redshift, Google BigQuery, and Hadoop. Hadoop is probably one of the more popular data lakes. These services store huge amounts of data that are used for a bunch of different purposes that we can extract specific things from. So many of you have heard the term, the buzzword, big data, and that's something that we should all be concerned about, whether if you pursue a career in analytics or not. Big data basically means that we have access to big data, large amounts of data, and larger than our businesses, larger than our own country even. We have all this data and we need to know how to analyze it. If you're pursuing a career in analytics, you need to understand that the trend and what's going to happen in future years is that when you're making business decisions or marketing, finance, data analytics, whatever it may be, we're going to have a lot more aggregate data, and we need to understand how to use big data. And a lot of times in the future, according to the industry professionals that we have connected with and talked to, is that the future, you're not just going to be looking when you're coming up with reports for your boss or when you're trying to solve a problem. You're not going to be just looking at factors within your business. A lot of times you'll be looking at aggregate and huge amounts of data. So we need to look to big warehouses or lakes. If the company that you work for doesn't have anything like this, then there's public sources where you can store data or even find out large amounts of data. There's lots of huge data sets too, like the GDelt. We'll talk about that. And anyway, so BigQuery, Redshift, Hadoop are places where huge amounts of data are stored. I'm sorry I keep saying data so much, but that's this class. So the one that we're going to be looking at this semester is, and using, we found to be a great simulation because it helps us understand SQL, how to extract things, and we found that it's integrated enough to where you can be flexible in exporting as a CSV, JSON, or even to Google Sheets, which is kind of nice. Google's something that we all have. Gmail, Drive, whatever it may be. It's something that I think most, if not all, people have an account with. Just a huge company that we figured this was a great service to use to really drive the point home that we can't expect to just grab huge amounts of data sources without overloading our computers, and plus, like, we want to make sure that you guys understand that we need to ask good questions and understand what kind of data we want to extract before we go diving into these huge sets. So anyway, Google BigQuery It's something we want to use throughout the semester. It's a massive warehouse where we pull multiple data sets from. In this case, I think we're going to use the GDELT as of now, and the Google Analytics sample files. It's free for 12 months, so if you sign up, it'll ask you for your billing information, but don't worry, you won't get charged for it. It's only saying if you go over the allotted monthly amount of queries, which is 1 terabyte, which is an obscene amount, and we don't have to worry about going over those, they'll charge you. Okay, but like I said, that's an obscene amount of queries, and you won't have to worry about that. There are a lot of free public data sets available on Google BigQuery, which is awesome, and you can use whichever ones you want to analyze. I think you can even use some for a final project as of now. Let's take a look at what BigQuery looks like. There's go to this link. It's the easiest way for me to for you to pull up the console of BigQuery, and there's a data set for common birth names in the United States. Okay, so let's take a look at that. Here's what the landing page, I think, for Google BigQuery is. It's part of a larger set of enterprise solutions called Google Cloud. Lots of data storage and other solutions like that. So let's take a look at what Google BigQuery looks like. So hopefully that link led you to something like here. Here's a quick start guide if you need it. A couple other tips here. You'll notice over here on the left that I have quite a few things. So to help you understand, right under this search box right here, I have a project. I think most of the time you'll want to start a project in order to get access to these. So it's a good practice, if you haven't already, start what's called, I think, a project. Give it any name, B315, big data sets, whatever you want to call it. This is where you can copy tables and queries into your projects. Okay, so you probably won't see these folders yet. Okay, you'll mostly see just BigQuery-public-data. So let's expand that. We're going to find the one with the, I think, birth rates or common names, and I believe it's under this sample right here. Yeah, the samples part under BigQuery public data, and it's natality. Let's take a look at that. This is one. Oh, I apologize. So this is just saying like birth rates and things like that. I think the one we were looking at was actually USA names for people. So let's just take a look at it. This is a really simple example of a BigQuery table and what that looks like. So whenever you pull up a table, that's what this little icon is. This 9x9 grid, or 3x3 grid. This is a table, and this is kind of a set of tables right here. Okay. And for some reason, there's two tables, one that says 1910 to current and one that only tracks it up to 2013. So let's take a look at the current one. You'll have something that looks like this, and a lot of times it'll be a lot bigger list, and there'll be a schema, a details, and a preview. A schema is essentially describing what the columns are, which is right here, describing them right here in this part of the table. It'll explain under each column what kind of format the values are in, and if it's nullable or required or things like that. You don't have to worry too much about this column for now. This is just saying like what kind of columns are. So take a look at the details. This gives us kind of where the data set's being stored right now. It's in the United States. If there's an expiration date, any sort of labels, when it was last modified, creation time, how many rows there are. So take a look at this. There's 5.9 million rows of data. So just a heads up that, to my understanding, I believe that Excel has a limit of between 1 and 2 million rows of data. So if that is the case indeed, then this is already too big of a file, and it's only 175 megabytes. Now, in previous videos, I showed you that picture of Bill Gates. Okay, he's showing the capacity of what a CD-ROM can handle, and this is in 1994. Now, if this CD is one of the top storing CDs out there, I think the most storage you can get out of a CD was a compact disc was 900 megabytes. So if that's the case, then let's just say this is 900 megabytes of data. You know, that's a lot. Even 175 megabytes is a lot of paper. So even if it's just down there, okay, he's way high up. So 175 megabytes over 5 million rows, almost 6, gives you a table ID, and this tells you sometimes it'll tell you the source, it'll tell you just kind of explain what it is. It kind of goes more into detail what the schema is. This breaks it down by column. If you hit preview, this will show you what the data will look like in table format. So you have the columns that were explained in schema right here, and it looks like it's just giving them the state code, the gender, the year, the name, and the number. And if you hover over the column title, it'll also show you the description that's found in the schema. So in this case, number of occurrences of the name. So in 1913, looks like there were 9 instances of people being named Harry. Okay, Howard seemed to be a more popular one. Okay, so this is a really simple data set, and a lot of times our data is going to be a lot more complicated than that. This is only 2 tables. Let's take a look at another one. Actually, let's just look at the Google Analytics sample that we're going to be using in class. So let's take a look. So it looks like there's only 1 table, but that's actually not the case. So GA sessions 366. There's 366 tables. That's what this parentheses means, that instead of listing all the amount, Google just decided to put it as 1 table, and you can filter it right over here under the table details of what it is. So let's take a look at this data. So this Google Analytics sample data set is real data from Google's e-commerce website. And to try to understand the data, there's tons of columns right here. We'll get to that in a second. But if we go in, there's 366 tables. It looks like each has the prefix of GA sessions, and it looks like a date. So it looks like we have dates from 2017, August 1st, and it looks like it's a table for each day of data. Okay, let's take a look at that. And it looks like it tracks it for a whole year, so from August 1st, 2016 to August 1st of 2017. So that's a lot of tables. Okay, let's take a look at the details. Just this one alone is 19.1 megabytes, 2,000 rows. You can try to combine the data, but it'll still be huge. Okay, here's the schema. This one's interesting because it looks like it has categories or records, and under each record there's columns. Remember, each of these values represents a column, and just imagine trying to sort through a data set with this many columns. It'd be quite annoying. Okay, and it doesn't look like there's a huge description either on these fields. All right. And yeah, so we got total visits. And so also to go over what this column means, you'll notice it's all in caps. And what this is saying is, in this column, data is being stored as an integer. In this case, just whole numbers. That's what an integer is classified under. A string is classified as characters, numbers, and letters of the alphabet. And there's another one. Let's see. Integer string. Boolean is another important one. This returns a value as true or false. This may sound familiar to those who have taken B215 in Excel. There's some of those formulas just return true or false. There's no in between. So this one's saying specifically, okay, it looks like, was it a video ad that was clicked on, true or false, something along those lines. And then there's also another type called float, which is similar to integer, and that's a number, but float is basically a number that contains decimals, or in other words, it's not a whole number. Okay, so that's just the basics of what that means. Okay, so let's take a look. Yeah, this is created. This specific table for this day was created and modified in this day where it's located. Let's take a look at the preview. Okay, this is where it's going to kind of look like a nightmare. Okay, so it looks like it's only loading one row for data for certain types of columns and a loader for others. So it looks like this data set is kind of incomplete, and it looks like it's pretty choppy and messy, lots of null values I'm seeing, and there's just tons of columns right here. Okay, this is going to seem very overwhelming. And so what we want to do, and what you'll do a lot of times when you're trying to analyze large data sets, is that you will query the data, which is basically asking for a specific set of data. So in the other example we talked about, you needed to get Pillsbury cake flour at Walmart, and your roommate's there. So instead of telling your roommate you want him to get you a bag of flour, you have to be more specific than that, and it'll only get you what you need. So he won't be bringing you back, bags and bags and bags of flour that has different types to it. You're asking for a specific brand, a specific size, and a specific type of flour. Okay, that's what querying is going to do. So query, by definition, is asking, is to request. So what we're doing is we're going to be requesting certain columns of data within this data set specifically. Now I've come up with a couple of queries, and this is what the SQL will look like. And I'm not going to walk through it exactly step by step of how to do the queries in this video, but what I do want to do is show you kind of how BigQuery works. So let's just pretend that we want to query that Google Analytics, and we came up with this awesome code to do it. Let's try to run it. Alright. It's going to tell me it failed. And so something unique to Google BigQuery is that for some reason it uses a dialect called SQL, or legacy SQL, excuse me. And if you click on this question mark, it says by default BigQuery runs queries using legacy SQL. And so for this purpose, this class, just make sure whenever you run a query you uncheck that box, use legacy SQL. Let's hide that. Let's try to run it again. And this is just going to use standard SQL dialect, and that's what we want. And this is showing right here how long it's taken to run the query. This one specifically told us it took 5.4 seconds and it processed 27.1 megabytes. So basically what this code is doing right here is it's scanning through all the tables between the dates August 1st, 2016 through August 1st, 2017. So it's going through all the tables. And what it's doing is it's calculating, it's taking some of these columns that we've seen in the tables and it's doing a calculation. It's doing an average revenue by user per visit. So basically saying the company, in this case the Google e-commerce website, is making $1.77 about per user visit. Okay, so that's all that I'm pulling. I'm not pulling all this data. I'm just pulling one value between that date. So you can of course adjust this to just do it by month and then change it. Another thing that I did, once you create these queries, is you can download this as a CSV or a JSON, or you can save it as a table where it'll show up in your projects, or you can even save it to Google Sheets, which is also very nice. This one, I don't know why I call it bounce rate, because it's not supposed to be bounce rate, but basically what this does is it shows us, I did another query where it showed me by user ID what pages they visited. Okay, this one's a lot bigger too. It's got over 336,000 rows, and it shows us, it just pulls these columns and that's it. It doesn't do any calculations, it just does these columns right here. Okay, so, and then what I did was that I saved it, excuse me, I think I just, yeah, this buttons are different, but it's basically going to tell you to save as a table, and it's going to keep it right here. That's going to be a lot easier, because from then you don't necessarily have to download it as a CSV, and sometimes even after you do these queries it'll be too big to export as a CSV. Now during the course of this, I just kind of want to explain, the last part of this video is explain connecting to BigQuery using Power BI or Tableau and some of the limitations and abilities that each has. Okay, so some of you may be thinking during this whole video, okay, I know already that Power BI and Tableau have a feature where you can connect to Google BigQuery. Okay, so, and that's very true. When you open up Tableau, you can connect to a server. In this case, you can connect directly to BigQuery. Okay, you can do the same thing in Power BI. Both, when you click on that option, are going to take you to a browser, I believe, and going to just make sure that you authorize the connection between Power BI slash Tableau and Google BigQuery. Okay, let me just walk you through what each looks like when you do that. So when I connect Power BI to Google BigQuery, this is what happens. It takes me to a file tree. Shows all the projects that I have. I can expand that, Google Analytics, and I can select a table. So after I make the queries that I want, this would make it a really easy way to import it into Power BI. Just go to your projects right then and there. Okay, so that's what we should be doing. Okay, now let's just say, okay, Peter, I want to pull up all the data from the Google Analytics sample? Well, Power BI, take a look at this. I told you the 366 tables. I would love to have all of you try to check all 366 of those and try to import that into your model without, destroying your computer or trying to overload your storage or processing power. Okay, it's just going to be kind of crazy. And even if you do get it that way, it's not a very ideal way to import your data or use your data. So and then within that, let's take a look at Power BI and see how it formats a lot of this data. Okay, try to expand this a little bit. Okay, so let's just pull up one data. This is, one table, and let's take a look at this data. Wow, looks messy, right? So it looks like it pulls up every single column, not every single column. It only pulls up the columns that aren't under records. And remember, there's a record for totals, and then within totals, there's tons of different columns. Looks like it formats this in a very ugly way. Now, that may be JSON, and I think there's a way in Power BI in which you can format this to be a JSON file type, but it's going to be kind of messy and cumbersome to try to load just this single data set in there and analyze it, as well as clean it up. It's just going to be a mess, okay? And really all you're going to end up with is the ones that aren't within a record that looks somewhat clean, and even those just, well, they can't really give you that much. Okay, so that's Power BI. Now, Power BI also has an API, and it's called let's see, Simba drivers. It's an OBDC, driver that you can install that basically makes it so instead of doing queries, SQL queries in Google BigQuery, you can do it within Power BI, and basically the process I showed you in Google BigQuery into Power BI. As of now, June 2018, that driver, at least for me, didn't seem to work very well. It's kind of complicated and had some bugs and permissions, and it was just kind of weird, so I just decided not to use that for Power BI. If you get it to work and you feel it's a better option, good on you. Once again, it's called it's a Simba driver for Google BigQuery, and I would do best to pause this video and copy this link, because if you try to go to the Simba Technologies company kind of thing and try to get the driver, I think they try to charge you or something really weird for that. I don't know. Okay, so that was Power BI. Tableau, let's connect to Google BigQuery then. Like I said, it'll ask you to sign in. Press allow. I think this happens about every time, and then you open up Tableau again. Okay, connected to it. Billing project, it'll sometimes have you select that. So you can select public data sets, or you can select your own projects. Now, the limitation with Tableau is that it doesn't seem to like loading all of these data sets that we found in Google BigQuery. For example, it only seems to load these 7 data sets in the samples folder. So going back, if we're going to the BigQuery public data, which looks like it's pulling it from there, that's okay. The only thing it shows up, it hides all of these, but it shows samples. And these are the ones that we see in Tableau. Okay. But I can pull up my own projects, and you can take a look. Let's see, Google Analytics. Yeah, it looks like it loads this table just fine. Now, let's say that you do end up finding a way to get the Google Analytics sample, all 366 tables, into Tableau, where it at least shows up, right? So I copied a table into Tableau from the GA session. So this is just one day of data from the sample set that I copied to my own, just for the purpose of explaining this to you. So if I try to view the data, update it, it gave me an error message. For some reason, Tableau, just the connection between Tableau and Google BigQuery for now isn't the best, in my opinion at least. And it looks like there's a way, without downloading an OBDC driver, you can query the data. But once again, it just, in my opinion, it seems like it's a little hard to try to do that, and kind of cumbersome, and doesn't work the way you want it to exactly. So what I do is I just go ahead and do it within Google BigQuery. Okay, so that's it for this video. I wanted to just kind of show you what data warehouses and data lakes look like, why we need them, what we're going to be doing with them this semester, and I'm not going to go into detail of how to run actual SQL queries in this video. I will in future videos, but this one, the purpose was to just help you understand what Google BigQuery is, how to kind of set it up for yourself, and how to read it, how to import it into Power BI and Tableau, and how not to do it. And yeah, so hopefully the takeaway that you get from this is that sometimes data is just too big and too vast, and instead of trying to max out your computer's features and qualities and processing power and storage and things like that, it's best to just query the data first, filter it down to what you need, and then using Power BI and Tableau